Yeah, very good morning to one and all. So today we are going to check about genetic algorithms in ML. So before getting into a concept called as genetic algorithms, before that we have to learn or we have to know some information or the fundamental things what we have to check. Okay, so let me see. So these are the flow of presentation. The first thing we are going to check it what is meant by machine learning and hypothesis space search, genetic algorithm, models of evolution and learning, and we are going to check out with a simple example. So that example is going to be ant colony optimization as well as particle swarm optimization. So how these two different real-time implementation can be going to be used in our real-time machine learning applications. So let's start with the first basic introduction about what is meant by machine learning and the hypothesis space search. Let us see what is meant by a genetic algorithm. So actually this is an inspiration of a particular or a well-known scientist. The person name is Darwin's theory of nature. So according to this person, actually how the real human lives has been evolved from the monkey and into a human beings. So in each and every stage or in each and every state, how we can able to propose our development into a real-time environment. So it is a heuristic search algorithm, which is going to be a hypothetical search. So inspired by Darwin's theory of evolution in nature. So actually, this type of uh, algorithms is mainly focuses to solve an optimization problems in machine learning. So what is meant by an optimization problem? So whenever we are having more number of possible solutions, from that we cannot able to say that this particular thing or this particular solution can be given as the final solution. Why? Because it may have a different working environment, different type of algorithms. So we have to check or we have to identify what is the environment we are going to deploy our algorithms. So this one we call it as optimization problems in machine learning. So it basically involves five fundamental phases. The first phase we call it as initialization, second one fitness assignment, selection, reproduction, and the final one is termination. So whenever we are starting with a process, actually it has to stop somewhere. That is, we have to provide the endpoint, or else it will go for an infinity number of execution. So the first step is initialization. So in initialization phase, I need to start to generate the multiple number of possible solutions. So this multiple number of possible solutions we generally called as population. So how we can able to call the human beings or the human lives as a population through the genes. So from parent, mother, then child. So this is how the initialization phase starts. So it's generally called as the collection of all the possible solutions and all the possible actors in that particular environment. Second one is fitness assignment. So it identifies how it is going to be the best one in a particular environment. So here I am going to identify how effectively it is going to be deployed in my algorithm. So each and every solutions that I obtain, I cannot directly go and implement it. So before implementation, first I need to go for how much best or better that particular solution is. And the third one is selection. So after initialization and fitness assignment, I need to go for selecting the particular reproduction or the particular target. So the particular target goes with a selection of the proper or the best suitable solutions. So this one we call it as a reproduction of offsprings. So offspring is nothing but the solution, the final solution that I am opting. The next thing is reproduction. So reproduction is a mechanism where I can able to generate the solution or output from the existing solutions or possible solutions, or I can able to incorporate or I can able to mix a newly found solution into my algorithm. So this one we call it as production. So we are going to see a simple example how your algorithms or operators we are going to deploy by using a concept called as crossover and mutation. The last phase is termination. So once if it identifies, which means if my algorithm once identified a solution, then it will be considered as the fitness solution, because from n number of possible solutions, this is the first time I'm going to evaluate. So automatically the first time evaluation doesn't have any threshold value. So the first solution will be considered as my threshold. Further applications or further feasible solutions will be considered after evaluation. Based on this first output, the further output will be get evaluated. So now we are going for how the reproduction is going to be performed. So reproduction is nothing but the set of algorithms that we are going to deploy or use. So the first thing is going to be a crossover. So what is meant by a crossover? So it is considered as already existing information or already existing solutions that I'm having in my hand. From that, I can able to combine two or more different possible solutions and I can able to generate a new solution. So this one we generally called as a hybrid. So which we combine already two or more algorithms into a single algorithm and we can able to generate, and this one is the possible solution or the best solution. So crossover means it started to swap the genetic information of two parents. So two parents are nothing but it is going to be already existing one from the offspring only. So from the current generation to produce a new individual representation of offspring. So offspring is nothing but the child or the solution, the finally obtained solution. So in crossover, we are going to collect the genes of parents and we are going to provide or we are going to give the resultant or child. So here we are having different types of crossovers. We call it as one point or a single point crossover, 2 point crossover, and a Liverley crossover. So 1 point crossover, one information from one parent, that is from mother, and one information from the father will be get replaced by some other value and it will produce a new set of values. Okay, it's similar to a union operation in a mathematics. And the next example is mutation. In mutation, not going to use the parent information or the parent genes. Instead of that, what I'm going to do is I'm going to gather some other outside, or this is outside focus. So new information will be collected from that gene. I'm going to induce some other new information, which is not already existing one. So this one we call it as a mutation. So in this type of mutation process, I will be having more different types of populations. So here population is nothing but we already discussed. It is the feasible solutions or the possible solutions, which I am having already existing one. So we can deploy in a real-time example. So we can go for real-time example as environment or a climatic or weather condition. In weather condition, already existing ones we call it as sunny, moisture, or it may be a cloudy or winter season, rainy season, like that. So if I started to combine this sunny as well as winter or sunny as well as rainy, so a new type of output may be generated and the output may be of new ones. So this type of combination we call it as a mutation. So we are having a different types of mutational algorithms: flip bit mutation, Gaussian, and exchange or swap mutations. So now we are going for a hypothesis space search. In hypothesis space search, so why I need a hypothesis? We know that an hypothesis is the different possible solutions which doesn't have a proof. But I can able to say that this one can be derived from this particular input, but I am not sure whether this one will gives you a positive or a negative values. So your output may be of positive or either negative. So the output cannot be predicted, but I can able to suggest this is possible through by only this particular algorithm. So then it is known as hypothesis. So it is a model's pre-assumption regarding the connecting between input features and the resultant. So I am telling that I need the future result as 2 plus 5 equal to 7. So now I am saying that 2 plus 5 equal to 7. Maybe your operator may be changed due to some error or syntactic or semantic errors. So your output may be produced as 35. So now the problem is my operator is different or it's going to be a waste one. So now I can able to replace this particular operator due to a miscalculation or a replacement. Now I need to get my output as 7. So I need to replace my operator as asterisk symbol to a plus symbol. So 5 plus 2, and it's not 5 star or 5 into 2. Okay, so this type of things I can able to evaluate. So here two terminologies we are mainly focusing on. One is called as hypothesis space and another one we call it as hypothesis. So what is meant by an hypothesis space? So hypothesis space is a collection or a group of all the possible or calculated resultant. So it may be proved in some location or in somewhere. Okay, so this one we call it as hypothesis space. Now we have to know what is meant by an hypothesis. Now from the hypothesis space, for our target or for our solution, I need to evaluate from the hypothesis space any one outcome is going to be considered for my output. So I cannot able to say all the output in or all the information in my hypothesis space is possibly to provide or to produce my hypothesis. It's not possible. So out of 100, one or two may be your for your environment resultant. Okay, so this type of resultant we have to search. So how it can be evaluated? So we have to target on supervised machine learning algorithms. So in supervised and unsupervised machine learning algorithms, a common monetary has to be there. That is a structured data set or already available data set only we can able to do in supervised machine learning algorithms. In unsupervised, no need of monitoring because all the informations or the data set is not going to be pre-assumed or previously available. Okay, so let me consider how we can able to calculate the hypothesis space search. That is HSS. So y equal to mx plus b. So here y is the range. So range may be first 100 elements I can able to consider for my problem statement. So now this is my range. So 0 to 100 is my range. M is the slope of the lines. Slope is nothing but whenever I am deploying my algorithm for that particular environment. As I said, we can't able to expect always I can able to get the positive result only. So in some situation, my output may be 99 percentage efficient. In some other place, it may be a 60 percentage or even it may be drastically dropped to not possible solution to even to a 0 point. So this type of slope, we call it as M. And X is a domain, the environment or the application where we are going to deploy our information or algorithm. So this is also considered as one main constraint because to environment, the type or the way of implementation, your threshold value may be changed and your input may be changed and your predicted output may be changed. So B is the intercept point. So whenever M is started to go up and down in some particular situation, some two or more lines, a slope may be get intercepted. So this intercepted point will be considered as a constant value because this constant value may be calculated for the future purpose where we can able to deploy a mutational concepts. Okay. So here only we are coming to our real time or the actual topic which is called to be genetic programming. So what is meant by a genetic programming? So here the computers needs to solve the given problem statement by its own based on the conditions that are given. So after generation, it has to generate some new type of outputs. The resultant should be a new type which is not going to be the existing one. Then it is said to be a genetic algorithm. So we can able to evaluate this genetic algorithm in the following 5 different steps. First, I need to identify set of terminals. So set of terminals are nothing but the final solution. So the final solution first itself I need to identify if I started to deploy this particular algorithm. The final output may be this. So the final target has to be evaluated first. These are the possible outputs I can be able to get if I deploy my algorithm in real time environment. The second phase is determining a set of functions. A set of functions are nothing but the slopes. So the next thing is the functions. What are the functions I am going to deploy in my algorithm? That is terminologies or I can call it as an attributes or arguments. Okay. So determining the fitness measure, I cannot able to directly go and say that whatever the solution I gain from my algorithm, I cannot able to say that this is the final solution or the best solution. So there I need to go for deploying a different set of algorithms in my model or in my environment. Finally, only I can able to by comparison. Finally, I can able to suggest that this output, whatever I'm getting, is providing an efficient one, the best result. Then it is said to be a fitness measure, that is the threshold value. Next one is parameters for the run. So what are the parameters I need to consider? For example, if I want to evaluate a soil moisture or the production of some crop, how I can able to improve my crop production. So there it's not only going to be based on the water. So I need to evaluate or I need to depend on moisture, temperature, type of soil, and some other constraints. Okay, so how much water contamination or how much water percentage of nitrogen, chloride, all this percentage has to be. So all these considerations I need to take. So this one we call it as parameters. Then the last one is determine the method for designating a result. How I can able to derive the result? Because if I am using some mutation, either I can able to deploy one set of mutation process, then that mutation algorithm is not working or not efficient. Then immediately I need to go for choosing the next alternative mutation algorithm. So I'm not supposed to depend on the same algorithm and try to deploy by using in different environments. So changing of environments is not good, but instead of that we can able to change the type of algorithms that we are implementing. So what are the different methods for a machine learning? First one is proposition and the next one is assessment. If a proposition is not suited for your implementation, then directly we can go for the assessment model. So what is meant by a proposition? So proposition can be defined as an experiences of a single organism directly affect the genetic makeup of their offspring, which means if this much of percentage of chlorine or this much percentage of nitrogen we can able to combine to provide a best solution, like that I can able to give for crop yield prediction. Okay, so this percentage, how I can able to evaluate? So this many number of genes or chromosomes I can able to combine with the female genes or chromosomes with this much of percentage. Then the offspring, then the child may be a male or a female. So this type of prediction we call it as a proposition, the percentage of mixture. If this one is not applicable, then by automatically I need to go for assessment based. So whenever the proposition is wrong, then directly I need to go for the concept called as assessment. So here what it is going to do is an individual is unaffected by the lifetime experience of one's biological parents. So which we call it as a mutation. So example, sequential covering algorithm. So sequential covering algorithm is one type of rule based algorithm. That is, the output of the previous statement will be considered as the input for the next level input. So this is what we call it as a sequential covering algorithm, that is in a hierarchical way. So how we can able to say that this person is elder brother or younger brother. So based on their age or based on their birth time. So this one we call it as sequential covering algorithms. So how your sequential algorithm works? So let me consider. First, I am considering a sequential covering. So here the attributes. So we can able to see the attributes, target attribute, attributes and examples and threshold. So until I am deploying the first implementation, that is I am getting the first output or the solution, until that the threshold value will be always resides 0. So it doesn't have any value till now whenever I'm running my first algorithm or the first training set. So target attributes is my output, that is going to be a single one, and the attributes are the possible solutions and examples the type of environment I'm going to deploy. So this four attributes I'm going to transfer. So initially learned rules is empty set, which means till now I have not calculated or evaluated a single algorithm or single input. Now I'm going to evaluate. The first input I'm going to consider here, rule is equal to learn one rule. That is the first implementation I'm going to take from the target attribute. That is my target resultant, list of possible solutions, which is considered as attributes, and the environment I am going to deploy. That is examples. I'm not using threshold anywhere. Why? Because threshold value is 0 still now. Okay, so now while performance of rule and examples, because we already said that sequential covering algorithm is a rule based algorithm. So performance of rules comma examples is greater than the threshold. So always it will be a greater than only, because initially the threshold value is 0. So always the value of this statement will become true. If this one becomes true, then I need to deploy, or I need to consider the first output as the best output or the best resultant. So learned rules is equal to learned rules, whatever the rules I obtained plus a rule. Okay, so this is my threshold value now. Now, how I can able to consider my examples? So example is equal to whichever the environment I deployed my sequential covering algorithm. For example, I am deploying my implementation in organization called as institution. So institutional organization. Now that particular example or environment has to be removed from all the possible environments, whatever the environment I can able to deploy. Okay, so minus examples correctly classified by the rule. Okay, so current value has to be removed from the already existing environment. Next, I need to evaluate once again rule is equal to learn one rule of target attribute, attributes and examples. So here in examples, previously evaluated or deployed environment will never be a part. For example, institution is not going to be in this particular arguments. Okay, so the remaining values will be evaluated or calculated here. So the last one, once again, I need to calculate the learned rules is equal to sort out. So because I obtained the threshold value now, because the first value whichever I obtained is considered as a threshold value. So whenever the same loop started to run for the next time or the second time or iteration, automatically the threshold value will be increased for sure. In case if it is greater than, then you have to evaluate the newly evaluated value as the best one. So this is what a sequential covering algorithm works. An example. So based on your genetic algorithm, we are going to see about two different examples and how it will be evaluated in machine learning. So first we will check with the real-time environment. After that we will go with the machine learning concept. So first, ant colony optimization deals with how an ant colony can able to identify the food resource and how it can able to transfer the food back to its house. So this is what the real-time application goes with. So in the first diagram, we are having a nest n and the available location of source, that is food. So from source to destination, I can able to have more than one different path, because it's not going to be a straight line until it identifies the solution or the target. So it can able to travel in different number of paths. The second diagram deals the ant will start from the nest and it started to go for searching of food by possible solutions. So this ant, the second diagram represents the different path that the ant can able to identify or evaluate. So this one we call it as feasible solutions or the possible solutions. And the last diagram, it deals with how an ant can able to keep a track based on the minimum path. Okay, because transferring of information is main. Okay, so whenever I'm finding a solution, it has to be a minimal one or optimal one. So optimal one is nothing but the best fit in that environment. If I am taking the different path, the distance coverage will be more. Okay, so the ants will started to communicate each and every one and to find the minimum path. Okay, so we'll see how it will find and how it works in your machine learning concepts. In the same way, let's consider the interpreter. Okay, so interpreter is nothing but we will consider like a human being. It's going to be a cloud or it may be a ML algorithm. Okay, so interpreter is like a human. Now I am giving the state, the initial status or the target is I need to identify the food resource where the food is available at. Now the agent will start to take the action. So agent here is nothing but the ant. Okay, so the ant will start to search for the environment that is for food resource. Once if the food is identified, what it has to do? So it has to acknowledge the food has been found in this particular location. So once if the food or the solution has been found in the environment, the person or the interpreter has to give a reward. If that solution is not the best one, the reward cannot be given back to the agent. That is the end. If food is not found, reward is not there. That is food is not there. So no reward will be given back. So let's consider how we can able to deploy the ant colony optimization algorithm by using machine learning algorithm. So let me consider we are having path 1 and path 2. Okay, in the previous example, we have come across path 1. Okay, so in the previous example, path 1 and path 2. So we are having two different paths from the ant colony towards the food resource. So then C1 and C2 going to the weight. So weight is nothing but the distance covered. So I need to find the minimal or optimal distance also. So how it can be evaluated? So each and every ant is not having eyes. So how it will be communicated? So some people will say it is communicated through the antenna which is having on their head. No. So it's not going to communicate through the antenna. It's going to be communicated through the smell or the chemical proportion that is released by each and every ant. Okay, so that chemical substance we call it as phenome. So phenome concentration is the liquid or the chemical reaction which is going to be released by each and every ant. So through this chemical percentage only, the ant will start to follow. Okay, so along the path. So initially the ith path. So here I is going to be considered as any path. So in P1 and P2, I am going to identify any path. Either I can able to consider path 1 or path 2. Okay, so ith path, then the probability of choosing the best or the efficient path is considered as Pi is equal to Ci divided by C1 plus C2. Okay, so where I may be the number of path or weight that the ant or our algorithm can able to identify. Okay, so always I cannot able to say that this particular problem is having the single solution. Okay, so the problem statement may have n number of different solutions. So that different solutions we considered as I. Okay, that is the path. Now, if C1 is greater than C2, that is path 1 is greater than the distance of C1 is greater than C2. So by default, C2 is going to be the minimum path. So I need to always go for choosing the minimum path only. Then the probability of choosing path 1 is more than path 2, which means path 2 can be get selected. Okay, so if C1 is lesser than C2, then path 2 will be selected and it is going to be the shortest path. So this is how we are going to select the path. That is the solution. How the concentration of prenome is going to be evaluated. So we always said the ant are going to follow their prenome consistent or the percentage. So whenever the chemical substance is released at initial, the maturity or the smell is going to be more. So whenever the path is going to be reduced, that means the ant is not going to travel in the same path. Then automatically what I can able to say that path is going to be disconnected, which is no ants are following that particular path. So in whichever path I am getting this substance or chemical smell in higher proportion, automatically I need to choose that particular path only. So how I can able to evaluate that phenome concentration? So Ci, so C we already seen the path or the weight or the distance that is evaluated. So Ci is equal to, if I already traveled in that particular distance, or if I already travel in that particular path, plus k divided by Li. So this k is considered as a constant value. So constant value will be always 0, 1, 2, 3, it goes on, and Li is the length of the path. Okay, so how much distance it can able to cover. So the chemical substance, how much it is frequently using. Okay, for example, in real time, if any student is taking leave, the default solution or the default reason they will automatically say is, I am not suffering well, or I am suffering from fever. So this is the continuous reason where they will started to roam around. So if a solution is frequently being used, then it will be considered as Li. Okay, so length of the path, the frequency that that particular reason or the solution has been being used. Now, when I need to change the concentration, whenever the chemical substance smell is getting reduced, okay, that is least frequently used solutions. So those solutions we can able to change our direction. So Ci is equal to 1 minus V into Ci. So already evaluated value is there, 1 minus V, that is already we are having a chemical substance that is already available solution has to be get subtracted from the constant value 1. Okay, so available minus not frequently used. Then automatically what we have to do is we have to change the path, or we have to change the type of implementation mechanism. And the next or the last most is particle swarm optimization. So we all know what is meant by a swarm. So swarm is nothing but a group of, is called as a swarm. So we will call it as a swarm of birds or swarm of bees, which means the first level, or the bird or the bee which is following the first layer, the remaining bees or the remaining contents will be started to follow along with them in the backwards. Okay, so backside each and every material or particle is going to follow. So how it can be deployed in our machine learning? So always said, we are having a start the procedure, that is we have to go for an initialization of particles. So initialization is nothing but we have to first identify the different types of solutions. So what are the different types of solutions we are having, and how we can able to implement the different type of environments we are going to deploy. Okay, so we are starting our flow. First one is initialization, that is collection of features. Solution evaluation. So here solution evaluation goes with, if a bird or if a bee is going for collecting or going to build its nest, automatically the remaining bees will started to gather there. Okay, so follows a single bee, that is the queen. Okay, so solution evaluation. If the solution is satisfied to you, whatever the solution I obtained is considered as the best one, then you can stop the process and you can able to give that solution as the best solution or optimal solution from n number of feasible solutions. In case that particular solution is not going to be an optimal one or the best one, once again we have to update the probability based. So p based is nothing but the probability based. Okay, so and n based. So if it is not satisfied, once again we have to go for updating our velocity and position, that is the distance and the probability we have to change. So velocity and position are nothing but the distance and the level, that is we can able to change, or we can able to consider it as position. So if you are checking with the real-time application, a group of birds will started to fly in some position. So it is not going to fly in the same location or position itself. So whenever the bird is flying too fast, that bird will fly in the first position. Whenever it becomes lazy or whenever it becomes tired, automatically it changes the position and some other bird will reach the high. So this is what it will happen. So here also same thing is going to happen. Whenever your algorithm is representing, this algorithm is not providing the best or the optimal solution, automatically that algorithm has to be withdraw its position and the next level algorithm is going to be get deployed. Okay, so how it can be implemented, or this is the algorithm. Okay, so same algorithm only. How we deployed here, ant colony optimization algorithm. So no change. You can able to check this. So once again, okay. And these are the different references that I followed to prepare this PPT and for preparation. And thank you once all. So thank you very much.